Hi, my name is Pramitra Sriram, and this is my presentation for the Charge Tapes Lab. Today we'll be discussing the following. First is the introduction, where I will discuss the purpose of the lab, the key concepts, and the preview of the experimental data. Next is the computational model, followed by the results, then the assumptions made, discussion questions, and finally the conclusion. Let's get into our introduction. The purpose of this lab was to identify and learn the following: the idea of charge, a property of matter, designing experiments using household objects, making estimates and simplifying assumptions, and the amount of excess charge on everyday objects, to then determine the amount of excess charge of one piece of tape. Here are the key concepts. First is Coulomb's law. This states that the force of attraction or repulsion between two charged bodies is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. This is represented by the formula here. Next is the electric field. The electric field is the field that surrounds electrically charged particles. Next is the gravitational force. This is the attractive force that exists between any two objects with mass. Finally, we have our Coulomb's constant, which is necessary for Coulomb's law and the electric field formulas. Next is the experimental data. We can see the measured distance, tape B mass, tape B length, and tape B width that were all figured out during the lab. Next is the computational model. Here we can see that particle A and particle B are both calculated using the position vector. However, for particle B, the J value vector is different. Then we have the radius, both of which we figured out earlier. Then we can calculate our force. Using this calculated force, then we can figure out the electric field. Next is the computational model. Here we can see that in the left diagram, the tape A is shown by the bottom force, and then the tape B is shown by the top force. The tape B charge is negative 1.86 times 10 to the negative 9 coulomb. We can also see this through our calculated results. As we can see, Q is equal to 1.86 times 10 to the negative 9 coulomb. This is the magnitude of the electric charge. Then we can also find the area of tape. However, this is using the assumption that the radius of an atom is 10 to the negative 10th. Then we figured out that the area of the atom is 1 times 10 to the negative 20 meters squared. Using this, we can find the area of tape to be 3.6 times 10 to the 3 meters squared. Then the number of atoms is 3.6 times 10 to the 17 atoms, and then the number of electrons is 1.161 times 10 to the 10. Next, we can move on to our assumptions. For the first assumption, we do not ignore air resistance on a moving object because once tape B floats, this becomes static friction. Next, we do treat a long tape as though it were a point charge because we can see that this is what we did for all of our calculations earlier. Finally, we assume that each U tape is the same amount of charge and is evenly distributed because the same processes were used to charge both pieces of tape. Moving on to the discussion cues. For our first what if question, there is no change if electrons had positive charge and protons had negative charge. This is because opposite charges would still attract and like charges would still repel. For the why question, it is important to handle the charged tapes as little as possible because if the tape accidentally comes into contact with any other object, you may accidentally ground the charged tapes, making them neutral instead of charged like the lab intended. Finally, we can go to our conclusion where we can find out that from the experiment, we were able to find that the charge of tape B was negative 1.86 times 10 to the negative 9 coulomb, signifying that this is the amount of charge required for one tape to float above the other. Thank you.